Hello. I'm sure some of you will have heard of the Action Replay cartridge. Datel or Datel made several different revisions for several different systems over the years. However, until recently, I didn't realise they made one for the Amiga 2000. Apparently they do, and here it is. But it's incomplete, and I have no idea if it works. So in this video, we're going to take a look at it, see if we can make missing parts, and finally, we'll see if we can get it working. So first, a little background. The Action Replay, available for several different computers, and still made for modern systems today, that's advertised as a way to cheat at games. Now focusing on the Amiga specifically, the Action Replay cartridge has only a few controls on it. You've got the slow-mo option that can slow a game down, a bit like the one on a previous video I did. And also a freeze function that triggers, like before, a level 7 interrupt. However, unlike that previous video, this doesn't need any special software loaded, as it's all stored in the onboard ROMs. From here, you can inspect the RAM, view registers, disassemble and rewrite the code in memory. It also comes with a disk copier called Burst Nibbler, a sound tracker, a picture editor, and so much more. And whilst all this is supposed to be used for cheating games, and I'm sure it was also heavily used to crack the copy protection on games too. Now, how the wizardry behind this sneaky board worked was a bit of a mystery. But there's an excellent write-up on this website down here. Don't worry, the link's also in the video description. And this website explains the clever tricks the Action Replay uses, so it knows exactly what's going on without even asking any of the custom chips, and how it can actually hide itself and be totally invisible to the Amiga. Which is really important, because if games could detect it, they could easily take steps to prevent it being used. Now there are some games that did find ways to trip it up, but we're not going to worry about that. So, let's take a look at the Action Replay I have. So, close up on the bench you can see this card. This is the Action Replay 3 for the Amiga 2000, and you may notice a few differences. Here, side by side, is the inside of the Amiga 500 Action Replay 3, along with my Amiga 2000 version. And you can see they actually look fairly similar, except mine is missing all of the controls. There's a series of holes here that look like they could be used to take an edge connector, maybe making it usable on Amiga 500. It also has this switch at the top to enable and disable it. On the Amiga 500, the Action Replay cartridge plugs into the side of the machine in a special expansion slot. On the Amiga 2000, it plugs into the CPU coprocessor socket, which is a bit of a pain if you intend to use an accelerator in that socket. However, the reason they chose to do this is actually fairly obvious. This is a pinout from the Amiga 2000 CPU socket, and this is the pinout for the Amiga 500 expansion connector. You'll notice that they're mostly identical, except the Amiga 2000 connector has a few extra connected pins, and a few that are slightly different. Now back to the card, this switch allows you to enable or disable the card. A strange choice to put here, as you'll have to open up the machine to access it. You'll also notice this connector. Well, this allows you to plug in the controller, which, via a long wire, goes into a handheld box that looks like this. But sadly, I don't have that part. Not to worry, I'm sure we can figure out what the connector does and how to make our own. This connector has 10 pins, and from a quick look, I can already see that some of these pins are simply not connected to anything. This pin here is a little bit strange. It goes through a 1K resistor, and then after travelling a long way all over the board, it ends up at the 5V pad on the edge connector. Looking at the other board, in the same position there's a green LED, so it's probably just a power LED. Now I can't see any kind of LED on the control box, so I'm wondering if this was put here and never used. Still, at least we can tick this pin off. Back to our drawing, and if we add a few more traces we can see that this pin is also connected to 5V, so that's another one we can mark off. Next up, if we can find 5V, it stands to reason there'll be a ground connection too. Well, if we take a look at this big chip here, and take a look at the datasheet and find the schematics, we can also see that this pin here is also ground, meaning we now know that this pin is also connected to ground too. That's another one done with. Whilst in this corner, I noticed this little chip here, and looking at its datasheet, it's a timer chip, just like the 555 timer. I'm not exactly sure what the difference is here. Now there's only one reason I can think of a chip like this being here, and it's probably to do with the slow-mo function. Interestingly, it has a connection to this pin, which also connects to this capacitor, all of which would be probably needed to make this chip work. So my guess is that this is the pin where the variable resistor needs to connect to. But just to be sure, let's take a look at the Amiga 500 version again and see where this pin actually gets connected up to on that board. And sure enough, it ends up at the variable resistor. This is a 10K resistor, but we're going to need to know where the other pins connect to. Unfortunately, looking at all the pictures I can find, I can't find enough detail to figure this out properly. and it's possible it might be wired slightly differently on the Amiga 2000 version as well. So for now, I'm going to guess that it'll connect to either 5 volts or the ground connection. So that leaves me 2 more pins. One of these is going to be freeze and the other one must be the switch related to slow-mo. So let's trace them out and see where they go. So following pin 2, we end up at this resistor. This is a 10k resistor and the other end is connected to 5 volts. So this will be some kind of switch input, I would imagine, with the resistor being used to hold it at 5 volts while it's not being pressed. This means it needs to be connected to ground to trigger it. Following it along the PCB and we end up at this PLCC chip here. Back to the Amiga 500 version, I'll trace that backwards and we can see that it traces to one side of the switch. So this must be the slow-mo switch. So that just leaves the final pin, pin 10, which has to be the freeze button. Let's trace it out and see where that goes. So this drops by another 1k resistor, again pulling the line to 5 volts, and then snakes its way around the board and ends up at the middle PLCC. So let's check what that connects to on the Amiga 500 version. And I'm very pleased to see it ends up at the freeze button. So now we know how this connector should be wired up. One last interesting detail I spotted, if you look at the Amiga 500 version, you'll see there's a red LED here, below the slow-mo switch, which is attached to this resistor. Going back to the Amiga 2000 version, we can still see this resistor, and it is indeed connected the same, however it's just floating with no LED connected. I wonder why they didn't remove this. Okay, so now I think I'm sure how it's wired up, I can have a go at building a replacement controller for it. I did think about putting all the controls on the 5¼ inch bay at the front of the Amiga 2000, that's this one here. Anyway, I've started designing a box, which I've tried to get as close as possible to the original based on photos around the internet. Once printed, it looks like this, and I've laid out all the parts needed. So, action replay assemble! Okay, so I have the controller. So what's next? Well, we need to get the Action Replay installed. Now apparently this only works with Kickstart 1.3 and I'm running currently 3.1, so that'll have to be swapped out. Not the most convenient of things to do, so let's get started. Right, let's power it on and see what happens. Okay, powering on, and it's trying to boot my hard drive, which is meant for Kickstart 3.1, so that's no surprise it fails, but there's no sign of the Action Replay. Maybe I missed it on boot. If it's working, it should show a splash screen when the machine resets. Still nothing. Okay, let's slide this switch across here and try again. Still no splash screen, but then this monitor keeps switching off. I'll try to reboot. Oh, and there it is, so the card obviously is working. Although it seems with this installed, my GVP card is now disabled as it's not trying to boot from it. I'm sure it's some sort of memory overlap or something, and I'm not worried about that, and I'm sure there's some jumpers I can change to probably fix that if needed. The question is, does it respond to my controller in any way? Well, the freeze button's working, That's exactly what should happen. So let's see what else works. I'm going to start by booting Lemmings. It was good for testing before and I'm sure it'll be good now. And I've sped up this boot sequence because it takes far too long. Okay, so the game's running and I'll flick this switch. And the game froze. I think this switch may be backwards as it's supposed to enable slow-mo, so technically in the on position it should be frozen. However, despite what position I put that switch in, the variable resistor isn't making any difference at all. I did say it may need to be connected to something else like ground, so I'll try that. I've rewired the box and I'm booting Lemmings again. I had to use a different area to solder all the stuff because, well, as you can see, my bench has a large computer on it. So let's try this again. Okay, so that made absolutely no difference. Well, there's only one more thing I can try, and that's to connect it to one side of the slow-mo switch. And as I'm going to be messing with that switch, I might as well turn it round to face the right direction too. Back to the bench and booting Lemmings again, and let's see what happens. Aside from me accidentally clumsily triggering the action replay, you can see that the variable resistor still isn't doing anything. Still, at least the slow-mo switch is the right way around this time. I've had a thought about this, and after retracing the PCB over and over and over and understanding the timing circuit in the corner of that board, I've come to one conclusion. The other end of that variable resistor has to be connected to 5 volts because nothing else makes sense. But maybe something else is wrong. After all, there's capacitors on this board. Once again, I couldn't show the soldering on this as my bench is somewhat occupied, but I removed the 2 electrolytic capacitors and have tested them on this simple meter. I'm not quite sure how good the ESR resistance measurement on this is, but that number is very, very large. So I've replaced them with new ones, reconnected the variable resistor back to 5 volts, and I'm now ready to do another test. I didn't expect this to be a recapping video. Booting up Lemmings again, and we'll try it out. Well, it still doesn't do anything. At least I haven't made it worse. Curious as always to know what was going on, I've brought in my scope again, and you can see here what looks like a charge-discharge pattern on the display as I turn the knob changes frequency. That proves that the timer chip is doing what it's supposed to, so either this is broken somewhere else within the action replay, or I just don't know what I'm doing. Oh well, I guess if anyone knows what's wrong, or has one they don't mind taking a picture of the inside, then please leave a message in the video description. I suspect most of the people that had these cartridges rarely use this function anyway, so what else can it do? Well, without this being a full tutorial, and I'm absolutely not an expert on this thing, you can use it to rip music from games. I'm booting from an old CU Amiga cover disc here, and it's got a demo of a game called Statics. I used to love playing this demo. Anyway, once loaded we can hit our freeze button and enter the action replay interface. By typing the word tracker, the action replay will search active memory for signs of music modules in a variety of different formats, and, when found, will display information about it, along with being able to play it, see the patterns, and also save it to disk. Now the action replay can do way more than this, and if you want to see more of that, I suggest checking out DJ Hoffman's Twitch and YouTube channels, because he covers this in great detail. I'm really pleased that the card works, and the controller I made, I think, looks kinda nice too. It's a bit of a pain, however. If I want to go back to using Kickstart 3.1, I need to open up the machine, swap the ROMs and disable the card using that internal switch. Not the most convenient of situations. So in the next video, we'll have a look at making that easier. One of the thoughts I had was that with the right adapter, this would probably work perfectly fine on the Amiga 500 too. So maybe that's another project for me. Anyway, I hope you enjoyed this video. Thanks for watching, and I'll see you in the next one.